This is a video about rewriting in standard form, and this is for a linear function. So for a linear function, the standard form is ax plus by equals c, where a, b, and c are integers, so no fractions or decimals, and a has to be greater than or equal to 0, which means that a has to be positive. And so all you want to do is rewrite the equation that you have so that it looks exactly like this. You've got your a, your x term, your term with x on the left side, your term with y on the left side, and the just number term on the right side. And you got to make sure that a is positive. If it's not, divide or multiply everything by -1, and that changes everybody's sign. So let's do an example. So for the first example, we have y equals -3x plus 7. So this is in slope-intercept form, and we're going to change it to standard form. So again, we want the x term on the left side. So I'm going to go ahead and add 3x to both sides. And so I'm left with on the left side y plus 3x equal to 7. And the only thing I need to do now is rearrange because the a comes before the b. The x term comes before the y term. And so you just switch their places. So you'll have 3x plus y equals 7. Now it's in standard form, and now we want to identify a, b, and c. So that's in standard form. Now we want to identify a, b, and c. So remember, a is the coefficient of the x term. So as a is equal to 3, b is the coefficient of the y term. So that's 1 because it's 1y. And c is the constant term in standard form, which is on the right side, and that's 7. So that's a, b, and c. The nice thing about doing that, having to do that, identify a, b, and c, is now you can make sure that you've satisfied all of these requirements. So, are they all integers? Yes. Is a positive? Or 0? Yes. So I know I'm in standard form. And another thing that you need to make sure of is that none of these numbers have a common factor. So if the actual a, b, and c that you found were 6, 2, and 14, that would be the result of me taking this equation and multiplying both sides by 2. So it would be the same equation because all I did was double it. All the solutions will be the same. So with 6, 2, and 14, that's still in standard form. But since I told you it's the same equation, which one's more correct? And that would be this one because you want it to be in the simplest form possible. There's no reason to have to double all those numbers. So you want to make sure that these three values, a, b, and c, don't have any common factors. And if they do, you want to reduce them. But you still can't have any fractions or anything. So we want it to be in the simplest form. So that being said, that is standard form for this equation. So these two equations are the exact same thing. This is just a different form of the equation that you write it in because we didn't change anything about the equation, we just moved stuff around. So let's do another example. This is another simple, straightforward example, so if you're doing okay with these so far, then I would skip ahead to the next example. But for this one, again, we need to get the a on the left side, the term with x on the left side. So I'm going to subtract 2x from both sides. And then I get -2x plus y is equal to 3. So I'm almost done. Everything's good except for the a is negative. So I want that to be positive, so I'm going to multiply each side by -1. And that just changes everybody's sign. So I get 2x minus y equal to -3. And now I'm in standard form. Another way you could have done this is to take that same equation, and now we're going to solve it where maybe you like that this is positive already, the a. So you can actually take the y to the right side, and make sure you write 0 there. If there's nothing else over there, you have to write the 0. If there was like a 3 over here or something, then you would just write 3, not plus 0. Since that was the only thing, you got to write 0. Don't lose your equal sign. But then you have 0 equals 2x minus y plus 3. Now you just need to take the 3 to the other side, so you get -3. equals 2x minus y. And now we just have to turn it around. Remember that that is the symmetric property of equality, that I can just write it the other way. Okay, it's not going to let me do that. 2x minus y is equal to negative 3. So I got the same answer, final answer, I just did it a different way. I don't care which way you do it. But now let's identify a, b, and c. A is equal to 2. B is equal to negative 1. You've got to have the sign. It's a negative 1, not positive 1. And c is equal to negative 3. So they're all integers, and a is positive. I'm in standard form. And again, these are the two same equations, just this one's written in standard form, this one's written in slope-intercept form. Let's do another example. So for this example, we have a fraction involved, so we're going to deal with that very first thing. We want the coefficient to be a whole number. So I really don't care about the numerator, I just care about the denominator. To undo that dividing by 3, I'm going to multiply by 3. So I'm going to multiply both sides by 3. You have to remember you have to multiply both terms by 3, not just one of them. So you'll end up getting 3y is equal to 1/3 times 3 is equal to 1. So it's just x and then minus 15. And now we can go about rewriting it in standard form. So this time I'm going to take it to the left side here. So I have negative x plus 3y equals negative 15. And now I'm just going to times everything by negative 1 to make that x positive. So I have positive x minus 3y equal to positive 15. And so that's standard form. Now let's identify a, b, and c. Oops. So a is equal to 1 because it's 1x, and then b is equal to negative 3, and c is equal to 15. So they're all integers and a is positive, so we're good. That's standard form for the equation y equals 1/3 x minus 5. Let's do another example involving some more fractions. For this example, we have a couple different fractions here, and I don't mind the obnoxious space here. I just didn't want to fix it. So we've got 2/3 x equals negative 1/4 y plus 2, and again, we're trying to put it in standard form. So we need the x and y terms on the same side, so we want it on the left side. So we can get rid of the fraction first, or we can move stuff first. This time I'm going to move stuff first. So I'm going to add 1/4 y to both sides. And then that gives me 2/3 x plus 1/4 y is equal to 2. Now let's deal with the fractions. Let's multiply both sides, because you always have to do both sides, by something to get rid of those fractions. So we need something that'll make these both whole numbers. Like I said, when you're solving an equation, you usually want this to be a 1 if you're solving for x, but we don't need it to be a 1. So don't multiply by the reciprocal, and if you do, if you multiply by 3/2, that'll change this 2 into a fraction, and we don't want that. All we care about is the denominator, so we just want to get rid of dividing by 3. But we also want to get rid of dividing by 4 in this case because we have a 4 in the denominator as well. So we want to multiply by a number that will undo dividing by 3 and 4. So in other words, a number that when we multiply by both sides, it'll make these reduce to whole numbers. So it's got to be a number that both 3 and 4 go into, and the smallest number is 12. So we're going to multiply both sides of this equation by 12. And I really didn't need to write it that many times, but just remember you've got to multiply it by every single piece because they're adding, they're two different terms. So if we do that, we will get 2/3 times 12. So we're going to be able to cross-reduce there, x plus 12/1 times 1/4, and we already know that's going to reduce to 3, equals 24. So we're going to be able to cross-reduce here. So we get 4 and 1, because divide each by 3, and 3 and 1, divide each by 4. And then so we get, we have to do multiply the numerators, the denominators are just 1, which is what we wanted. So we've got 8x plus, and then we have to multiply this one, would just be 3, y equal to 24. Now those look like big numbers, but none of them have a common factor. Not all three of them, I mean. All three have to have a common factor, and they don't. So we know we're going to be okay. And then a is equal to 8, b is equal to 3, and c is equal to 24. So again, we can see no common factor, so we're simplest as we can be. All three are integers, and a is positive. So that is standard form for this equation. Let's do another one. For this example, we've got 2x plus 3y equals 0.2. Looks pretty good, so I think we're done. But we're actually not. So that 0.2 is giving us trouble. We have to have the number portion also be an integer. So to make 0.2, which is really 2/10, to make that a whole number, we're going to multiply by 10. So we're just going to multiply each side by 10. And that just moves everybody's decimal. So it's going to be 20x plus 30y. I don't have my good stylus, so I'm not writing very well. Equal to 2. And now we can see that we actually have a common factor here. So multiplying by 2 by 10 caused us to have a common factor between them all. So now we need to divide everything by 2. So divide by 2, and so we really have 10x plus 15y equal to 1. So that's fine that we had 2 steps to do that, but if we, in the beginning, we could have written 2/10 as 2/10 and then reduced that to 1/5, and then see that we only needed to multiply by 5, not 10. So just be careful when you do that. When it's written as a decimal, you might multiply by too much, but then think you're okay, but you always got to look and make sure that you don't have a common factor between each of them in the end. So let's identify a, b, and c again. So a is equal to 10, b is equal to 15, and c is equal to 1. And that's standard form. Let's do another example with a lot of fractions in it. In this example, we have 3 different fractions we have to worry about. So we need to get rid of dividing by 7, 3, and 5. So we're looking for the least common multiple of 7, 3, and 5, because multiplying by that will make all 3 of these fractions reduce to whole numbers. So we're just going to multiply them all together. That usually works, but it won't always give you the least common multiple if 2 of the numbers have a common factor. But none of them do for this one, so just multiply them all together. 7 times 3 is 21, times 5 is 105. So I've got to multiply both sides by, and that's a multiplication sign, by 105. So then I'm going to get a few fractions. Here I've got 105 over 1 times 6/7 y minus 1, well, not 1/3. I want to do 105 first, because we have to multiply everything by 105. 1/3. And that's a positive 1/3 because I already have the negative over here. And then equals 105 over 1 times 2/5 times negative 2/5 x. And now we can start cross-reducing. So we can do 105 and 7 are both divisible by 7, and we made it that way, so it should work. And 105 divided by 7 is 15, so we got 15, and we still have to multiply that by 6, y, minus, and then we do 105 divided by 3, which is 35. So 35 y, oops, I forgot the y up there. Y, or no, it's not a y, just kidding. So minus 35 equals, and then we can reduce this. 105 and 5 both go into, 5 goes into both, so this would be 21 and 1, and so we still have to do 21 times 2x. So now 15 times 6 is 90. So we have 90y minus 35 is equal to 42x. Now I can see there's no common terms between them. So I'm okay. Now I need to rearrange this. And this was supposed to be negative back here. So I'll fix that. And now we've got negative 42 here. So now I can start rearranging. So I'm going to add the 42x to the left side so I can make it positive and get it with a y. So I'll be left with 90. Well, I'm going to write the x term first. Make it easier on myself. So 42x plus 90y minus 35. Like I said, there was nothing else on the right side, so I have to put 0. Equals 0, and now I can just add 35 to both sides. And 42x plus 90y is equal to 35. That's standard form, so A is equal to 42, B is equal to 90, and C is equal to 35. So we had some big numbers there. That's okay, we can deal with it. And that's standard form of that previous equation. So to review, to be in standard form, you need to have the x term and the y term on the same side, that being the left side. But if you end up on the right side, use symmetric property to just turn it around. And then you got your other number, your term with just a number on the right side. A, B, and C all have to be integers, meaning no fractions, no decimals. And A has to be positive. Also, A, B, and C cannot have a common factor. If they do, you need to reduce the equation. So if you can rearrange an equation to look like this, that's all you have to do to rewrite something, a linear equation, into standard form.